Hi, hello everyone. Welcome to Code Conyo. So for today, we are going to talk about Venn diagram and sets operations. So Venn diagram is a diagrammatic representation of all possible relationships between different sets of a finite number of elements. Venn diagram were conceived around 1880 by John Venn, who is an English logician and philosopher. They are extensively used to actually teach set theory. So Venn diagram or Venn diagram is also known as in other books. It's known as primary diagram, set diagram, or logic diagram. Now let's talk about each of the set operation in a set. Okay, so let's talk about union set. So when you talk about union set, the union set is going to it's a set that is defined as a set of elements which are either in set A or in set B or both A and B. So meaning to say the elements are going to be united as one. So let's say for instance we have here the set A, which has elements 2, 5, 7, 8, 12, and 10. And then we have also here B, which are 4, 8, 10, 11, and 15. Now, if we're going to create a union of these two sets, we are able to come up with 2, 4, 5, 7, 8, 10, 11, 12, and 15. So now, as you can notice, the highlighted, what we call this one, highlighted part in our diagram, this is what we call the common elements, which are basically 8 and 10, while the the A union B are actually called as the quadrilateral A union of B. So basically, we in if we're going to use the unions of two sets, we are going to combine the elements of two sets. And notice that when you combine two sets, and if there is such element that is, let's say, uh, elements that are actually repeated or redundant. So when it is going to be combined, it is going to be avoided or something like omitted in the as if you're going to combine two sets. Okay. So now let's talk about intersection set. So when we talk about intersection set, this is a if you have two sets like A and B, the elements now are uh, the what the you'll have to determine the overlapping parts of these two elements. So basically, if you have two sets, the same with what we have earlier, A and B, so you will just have here if you're going to depict the intersection of two sets. So we have here only 8 and 10. So we're going to uh, remove or eradicate the sets that are not common to both sets. Now, the elements that are not both common to the two sets. Therefore, hence, we have only remaining elements after intersection 8 and 10. Okay, so what about set difference? So when you talk about set difference, basically, you'll just have um, to subtract the difference, subtract the one set by another set. So this would mean that the set contains exactly all the elements in A but not in B. So using the same set of elements in A and B, so we have here, if you will get the difference of um, set A and set B, we come up with 2, 12, 5, and 7. So the only elements that is going to be remained on the set A are 2, 5, 7, and 12. Okay, so how about symmetric difference? So symmetric difference, basically, if you have two sets like A and B, is the set of all the elements which belong to exactly one of the two original sets. So this can be written either using the triangle or symmetric difference symbol. So let's say we have two sets here, A and B. The same with what we have, the same elements that we have earlier. So if you're going to get the symmetric difference of the two sets, we have here 4, 5, 7, 11, 12, and 15. So as you can notice, if you get the difference or the symmetric difference of two sets, the you'll get the elements, and you'll have to eradicate the elements or omit the elements that are common to them, leaving the elements with 2, 5, 7, 12, 4, and 11 and 15. So I guess that would be all for the basic set of operations. And thank you guys for watching this video. Have a great day. See you guys soon. Bye bye.